Hello friends, thank you for showing your interest by enrolling for the course. From Craving Gyan YouTube channel, we have come up with the course for UGC NTA Electronic Science Paper 2. Paper 2 consists of 10 subjects. The first subject we have taken or we have chosen to be network analysis. So let us try to discuss with respect to the prerequisites that is very much necessary in order to study this subject. With the help of network analysis, we shall discuss with respect to or we can handle the subjects of control systems, signals and systems and analog electronics also. Hello friends, this is Arun Kumar here. I welcome you to my channel Craving Gyan. If you are visiting first time to my channel, make sure you're going to subscribe to my channel and click on the bell icon to get instant notification whenever I upload a new video. Please do inform to your friends in order to enroll for the sessions. Welcome to the course for UGC NTA Electronic Science. So in the demo class we have talked about network analysis. In the network analysis already I have discussed with respect to the syllabus point of view. Now the first subject I am going to take network analysis. So if you are having any restrictions or you want to change with some other topic, you can come up with your opinion. All of you are comfortable with networks? Hello? I'll be starting from the basics.
Yes, sir. It is great, sir,
Okay.
to start with.
See, in the demo class, I've talked about networks, and in the networks, we have did a wave classification regarding the passive elements and active elements, linear network, bilateral network, linear and non-linear network, unilateral and bilateral network, and also I've told you will be having three variants of resistance, right? And if the resistance is in series and it is in parallel, what is the equivalent form? And say suppose inductors and capacitors, passive element and active element, these things we have discussed. Whatever I say, just try to make use of a running notes. At last I will be sharing the PPT. In order to study this network subject, what are the prerequisites? Prerequisites are, say suppose in your physics and in your 12th, or say suppose in diploma you have come across with respect to KCL and KVL, and even in engineering also you have studied this KCL and KVL concept. That KCL and KVL concept, if you are knowing, that is more than enough in order to solve the network problem. Nothing but circuit wise you can easily rig up. If you want to find voltage and current, if you are knowing this KCL and KVL, this is more than enough. Or say suppose if you are in a position to write the nodal equation, and if you can able to write the loop or mesh equation, this should be more than enough in order to solve any given problem. But before that, in a node or mesh, what is the things you are going to consider means, you are going to consider the passive elements, nothing but resistors, inductors and capacitors. Also you are going to speak with respect to the voltage source and current source. Now look at the things. Let us talk about what do you mean by a resistor. A resistance is the one which opposes the flow of the charge carriers. In the sense, we are going to talk about the current. Now if you are talking with respect to the current, we will be having two variants of current. Can anyone tell me what are the two variants of current we will be coming across or we will be dealing across?
ACDC.
AC and DC, this is one type, and but if we are strictly speaking with, we will be having two variants of current because of the charge carriers. Okay, let
Holes
me
and
electron. Let us deal with the charge carriers. So we will be having this whole current, and we will be having one more is we will be having electron current. We will be having electron current. If I am speaking with respect to an whole current, this whole current is due to positive charges. This electron current, it is due to negative charges. Now whole current is nothing but the conventional current we are going to take. The whole current we are going to refer to a conventional one. Now this electron current is nothing but the movement of charge carriers. It is forming an electron current. Absence of electron, as of now you consider it is a hole. See, mark my words, for as of now you try to consider the absence of electron as a whole, but in EDC we will straight away violate this statement. Absence of electron is not a whole, we will be explaining in the EDC subject. But In networks, you try to take this absence of electron as a whole. Absence of electron, you try to consider it as a whole. Now, look at the things carefully. Look at the things carefully. What we have told is absence of electron is a whole. But in EDC subject, we will be violating the statement. We will be violating the statement. Throughout the network subject, what we will be discussing or what we are focusing is, we are focusing on whole current, not on electron current. Keep these things in your mind, right? Throughout the subject, we will be dealing with whole current, not the electron current. Nothing but, say suppose you consider you are having some battery kind of thing. Always you will be taking the current that is moving in this direction. We will be taking the current as high. Strictly speaking, positive battery means it will try to take the electron, but we are talking about giving the whole. We will be talking about giving the whole. This is one thing what you have to understand. Now, the amount of charge carriers that is flowing through, say suppose given a cross sectional area, and that current and that flow of charge carriers is taken as the current that is high. Current I. Now the symbol of resistor I have written over here, and I am going to represent by R, capital R. Now what is the current that is getting into the resistance, and what is the resistance that is offered by a material, and that's how you are going to define a voltage. That's how you are going to define a voltage across a resistor, right? So here voltage is nothing but, say, current drawing capacity or current withdrawing capacity. In this way I can tell. Say suppose voltage is more, current is also more. Voltage is less, current is also less. Provided the path should be a closed path. In my engineering subject, the subject name was network theory. In a few other university, the subject name was current theory or current analysis. Now what is the difference between networks, and say suppose if I am speaking with respect to the current, the concept over here is, in the case of network means what, at least you will be having one open path. See, say suppose here there are some elements and you will be having the battery. Here you will be having the elements. Here also you will be having the elements. Some elements is there, right? At last you will be having one open path. Do exist, right? Their current is not flowing. This is vague way of explanation. Right? Now, with respect to resistor, keeping resistor in our mind, we have discussed with respect to what is the voltage, what is the current, what is the resistance. Now, based on this, let us discuss what you people are really aware. See, we will be dealing with respect to the Ohm's law. Straight away, if I am asking to any person what do you mean by Ohm's law, what he or she will be telling is, take a conducting rod. The current that is getting into is directly proportional to the voltage that is being applied at constant pressure and temperature. If I am removing the proportionality constant, what I will be getting is I equals to V divided by R, or V equals to I into R. But strictly speaking, this is not only Ohm's law, it is one of the form of Ohm's law. We should be knowing all the 9 forms of Ohm's law. One of the form of Ohm's law is I equals to V divided by R. Very important, right? Till now, any doubts? Hello?
No, sir.
No doubts? Okay. Chalo, let us continue with the things. See, similar to this, we have written I equals to V divided by R, nothing but I is proportional to V, nothing but it is a linear component. It is a linear component. Why it is linear component means, see, we will be taking it as this equation is something like y equals to mx, not y equals to mx plus c. When the equation is something like y equals to mx, its nature of behavior is passing through origin. Nothing but on the x-axis I will be taking voltage, and on the y-axis I will be plotting with current. So if I am increasing the value of voltage, what I will be getting is there will be a sufficient increase in current also. What is the thing that is going to happen means, any increment change in voltage will have an increment change in current, So can I tell the resistor to be a linear element? The resistor to be a linear element. The resistor to be a linear element. Now, one more thing. When you try to connect a resistor on a spring board or in a breadboard, are you connecting from left to right or right to left? Doesn't matter. However you want, you are connecting. But power supply, positive to positive, negative to negative, or common thing, you try to connect to ground only. So that means what? The orientation of placing is not at all important. So I can call it as a bilateral element. When I will be discussing with respect to bilateral element, I will be talking about the quadrants of operation. Right? So it is a bilateral element. First thing is, it is a linear element I have discussed, then bilateral element. And look at the things. How much ever you give voltage across this resistor, there will be a drop across it. As long as you supply voltage, its duty is to dissipate the power. Is it in a position to generate energy on its own? No. When we were the students, we were asking money from our parents only. Nothing but we are depending on our parents for wealth and health. So this resistor is considered to be a passive element. Let us talk about the power dissipation. Is it dissipating the power, or is it absorbing and it is storing the power? No, it is not at all storing the power. Now let us consider myself. See, when I was a college going student, say suppose if my father is giving, assume, say suppose 50,000 he is giving. The college fee is, say suppose 50,000 I will be giving it. Say suppose if they are giving 1,000 in a month for as a pocket money. So what we were doing, 1,000 we will be spending. Assume like this, 1,000 we are spending. Say suppose if he is increasing to 2k, we will be spending the entire 2k. Say suppose if they are increasing up to 10k, what we were thinking is, okay, last month we have spent 1,000, this month let us spend 1,000, like that. The boys mentality will not be like that. So what we will be doing is, entire 10k we will be spending. Now here you please think about what is the scenario. How much ever you try to supply, that much of we are making it to jump. Nothing but we are dissipating, we are spending. In a short sense, what I mean to say is, we are not at all storing. But with respect to inductors and capacitors, it's a different story. They are considered as a storage element. So here it is. not a storage element, not a storage element. And with respect to power, it is a power dissipating device, power dissipating device. Nothing but what? Heat is getting dissipated, heat is getting dissipated. It is not at all storing. It is not at all thinking that, see, from past few years I am keep on dissipating, from now onwards I should store it. No, no. Few things we can't change in our life. Something like this only resistor is going to behave. Right? So quickly, if I am recapping with respect to the resistor, what is the voltage drop across it? I am taking it as V, and what is the current that is getting into? I am going to take it as I. What is the resistance that is offered by a resistor? That like with respect to the material, I am going to take it as R. So with respect to Ohm's law, we got I is proportional to V, and taking the proportionality constant, I am going to get I equals to V divided by R. Now, with respect to this, I have made some like I have come up with some conclusion. A resistor, it is a linear element. A resistor is a bilateral element. A resistor is a passive element. A resistor is a power dissipating element. A resistor is not a storage element. Resistor is not a storage element. Up to here, if you are having any doubts, you please get it clarified then and there itself. You please get it clarified then and there itself. Let us talk about inductor and capacitor. Let us talk about inductor and capacitor. This inductor and capacitor are two funny characters that we will be dealing with, dealing in only network subject. In rest of the subject, say suppose in control system, wherever L is there, I will be taking the Laplace transform, I will be taking it as SL, and wherever the capacitor is there, I am going to take it as 1 over SC. I will be taking it as 1 over SC, and then we are going to deal. But as of now, let us not talk about inductors and capacitor. Let us talk about voltage source and current source, and let us come back. And later we shall talk about inductors and capacitors. Why means this inductors and capacitors are something like a serial, right? Minimum 1000 episodes are required in order to deal with inductors and capacitors. Right? So don't worry. Let us talk about inductor and capacitor. But before to that, let us talk about voltage source and current source. Let us talk about voltage source and current source. Tell me what do you mean by voltage source, and tell me what do you mean by current source. All of you, I request you to do a proper interaction. Tell now.
Sir, voltage source is a combination of the charges, or in which the it is of different types. Means AC, DC. There are two types. And, so that is the reaction is taking place, chemical reaction.
Now, look at the things. Networks is like initially only I told, dealing AC voltage and dealing DC voltage, it is we are not at all clubbing. We are dealing the network subject separately, nothing but DC excited and AC excited. Things, let us get it cleared. Separately we are discussing, we are not at all mixing. Similar to that, we will be having say suppose it is DC excited, we are going to take it as DC voltage source, and say suppose AC supply is there, AC voltage source. But since here we are discussing with respect to DC, let us fix it. Now, with respect to voltage source means what? Some source, something is there that is giving voltage. Something, some one X commodity is there, it is giving the current. So that commodity, when it is supplying the voltage, we are going to call it as voltage source. That one commodity, when it start giving the current, then we will be calling it as current source. This is the vague way of explanation. Now, here also there are two scenarios. Here also there are two scenarios. See, say suppose if any person is asking you, are you very much studious? We will say yes, I am very much studious. but we know that how much we are studious. But for the outside world, we will be telling that no any student is better than us. Why? We are having something like ego problem. Something like ego problem. That's the usual mentality. Similarly, in this also, we will be having or we will be dealing with respect to ideal voltage source, and we will be dealing with respect to practical voltage source. Nothing but, see, a voltage source, when it is taken as ideal, when it is taken as practical, let us try to analyze. Let us try to analyze. Before to that, let me give one example. Say suppose you are having double A cell battery, right? At 15 rupees, 16 rupees battery you will be having, no? That one only you consider for the exploration. A small knob kind of thing will be there, or bubble kind of thing will be there. That one is a positive, and the other side will be a negative charge or negative supply. Now look at the things. When you try to connect a multimeter, and when you try to make a measurement, exactly it will be, say suppose 1.3 volt. Say suppose exactly it is 1.3 volt. 1.3 volt is the voltage drop across it. Now this is in the ideal scenario. Similarly, this battery, what I try to correct is, I try to correct to a load. Not a simple load, something like complex load kind of thing you assume. So at that time, what we expect is, since it is connected even though in parallel, we expect the voltage drop across this one to be 1.3 volts, but we are not at all getting 1.3 volts. Say suppose we are getting 1.25 volts. Now here the question arises, where is that 0.05 volts? Even the voltage is less, even the internal voltage drop is less, we should bother that small value is the internal resistance being offered. Because of the internal resistance that is being offered, we are going to consider this source to be a practical source. Nothing but what? That source itself is having the internal resistance. That voltage source itself is having the internal resistance. Unable to follow, don't worry. Only one example, only one question I will be asking. Yesterday, assume that yesterday I have taken non-veg. You assume that I have taken non-veg. 1 kg of non-veg I have taken. Assume, no problem, 1 kg of non-veg I have taken. Usually the calorie count, what it says is, say suppose, assume that X amount of calories I have consumed. Is all the X amount of calories converted to energy? No. Some of the food is getting wasted, or it is being thrown out by our kidneys through excretion. Here what is the thing that is going to happen means, a simple thing. We are consuming X amount of like calories or X amount of quantity as input. We are using only Y amount. That Y amount should be very much less than X amount. Ideally what we say is, whatever we are consuming, it should be useful. In other sense, you see, we will be studying for 3 to 6 months. In order to get clear with the UGC NTA. We will be studying the entire topic, like that we assume. I have studied with the entire subject. But after exams, you ask yourself, are you in a position to attend all the questions? Leave it. Are you in a position to attend at least 80% of the questions? What we say is no. Why? We thought that the syllabus is only this much, but it is vast. Some of the concepts we have not covered. Simple sense. We are knowing why to read, like that. some of the topics we would have skipped it, or we have not done proper revision. Due to lack of revision, we will be leaving some of the topics. When we are leaving that some of the topics, our mind is something like a practical voltage source. It is not in a position to give out all the things what we have studied. It is not in a position to replicate fully. Ideal brain means what? Whatever we have studied, each and everything should be thrown out, or it should be replicated during the exam. But really really is it possible? No, not at all possible. So I guess this is the best way of explanation with respect to voltage source and current source. But with respect to network subject, like this, if you are explaining, it is wrong. What they expect is explain in terms of voltage and current. Explain in terms of voltage and current. Now what do you mean by voltage source? What do you mean by voltage source? What do you mean by voltage source? Say suppose if I am applying some current, whatever may be the current you try to apply, voltage should be a fixed quantity. This voltage should be a fixed quantity. This is one way what the textbooks deal. With. And the second way is, see, voltage like this they are going to take. Current like this they are going to take. But the best possible, the characteristic is the first one. Whatever may be the current value, I am going to generate a constant voltage. So this is ideal voltage source. Now, what is practical voltage source? As load increases, its behavior is also going to deteriorate. Nothing but what? We expect the voltage to be constant. But we are not getting a constant current. This is practical voltage source. Any doubts? Hello? In the case of practical voltage source, as current increases, voltage decreases. Why voltage is getting decreased means, see, it's a potential. Say suppose this is my battery. It is having some internal resistance. What is the terminal voltage? Say suppose E over here and R. What is the voltage you can able to access is V equals to E minus of IR. See, here we try to connect a load resistor. As current increases, what is the thing that is going to happen means IR drop also increases. When IR drop increases, V decreases. When IR drop increases, V, nothing but terminal voltage decreases. Right? Able to follow? Hello? All of you, please respond, no?
Yes, sir.
So, we have talked about voltage source. We are having two variants of voltage source, ideal voltage source and practical voltage source. How they are going to represent this ideal voltage source? Something like this only, E. It will not be having that R term. The terminal voltage is V. But you talk about the practical voltage source, here you will be having the internal resistance, call it as, I'm going to take it as small r. If you want to take it as capital R, nobody is there going to restrict you. Whatever the notation you want to follow, you can follow. Right? So this IR drop, wherever it is there, we will be taking it as practical voltage source. Throughout the subject, we will be dealing with respect to ideal voltage source only. in all the cases we will be considering that internal voltage drop is a low value. That internal drop is the low value, right? This is one assumption we will be making. Even in analog electronic subject, especially if I am dealing with respect to op amp, first what we are going to consider, under ideal scenario only we try to explain, but extension part what it say is virtual short is not applicable. Why? This inverting terminal value and non-inverting terminal voltage is not the same. They both are not the same. At that time we will be talking about the actual, we will be speaking with respect to the actual characteristics of an op amp, actual characteristics of an op amp. But you see, you try to attend the problems in UGC NET. All the questions are under ideal scenario only, but you try to take the gate questions, minimum 40 to 30% of the questions will be from ideal, rest all the questions will be under practical scenario only, under practical scenario only. Now here I try to talk, or I try to discuss with respect to a voltage source. Let us talk about the current source also. Let us talk about the current source also. I can tell you the opposite of the voltage source will be current source. No, I should make a proper explanation. I should make a proper explanation. In the current source also, see, you will be having the two variants. You will be having the two variants. The first variant is under ideal scenario. The first variant will be under ideal scenario and the second variant will be under practical scenario. Ideal voltage source and practical voltage source. Now, what do you mean by this current source? Means what? Irrespective of voltage, current should be constant. Irrespective of voltage, the current it should deliver constantly. Current should be constant. Now, upon explaining all the things, what students they will be asking is current source existing? Is current source existing? What we say is yes, current source do exist. For that explanation, if you want, means let us get into some series of lectures. You want to tell the example, I will be telling. See, in the digital camera, we will be inserting that battery. Say suppose a 4SSL battery we are inserting, or nowadays it is a rechargeable battery, or nowadays it is a fixed batteries we are going to insert. That battery is acting like a current source. In what sense it is acting like a current source? Let us talk about it later. As of now, let us talk about the characteristics of it. Same way you try to write and you try to copycat it. Now here on the x-axis, what we are going to take means voltage you try to take. Whatever may be the voltage value, current is constant. Current is constant. Nothing but, see, few students are there, whatever may be the family pressure, irrespective of family pressure, what they are going to do is they are least bothered with respect to the family pressure. Their main ultimate goal is to crack one of the exam and try to get settled in their life. So that means what? They are studious enough. They are thinking that today's problem will not be tomorrow's problem. Today's problem will not be tomorrow's problem. Today, yes, problem is there. Tomorrow it will get settled. Tomorrow it will get settled. So that means what? They are focusing on. They are focusing on their goal. They are focusing on their goal. So this is something like, if we are maintaining that mindset, then we will fall under ideal current source. We will fall under ideal current source. But what we think is, say suppose today, if you like from past 1 month I am doing CVA preparation. Assume that today is a Deepavali festival. That means what? Today we are not at all focusing. We are into festival celebration mode. Festival celebration mode. That means what? Today's preparation we have lost. Today's preparation we have lost. And moreover, today we have not done revision. Tomorrow what it is going to happen? It will be bit hectic. Say suppose today and tomorrow, day after tomorrow, all 3 days your relatives are staying in your house. So that means what? You are getting distracted. When if you are getting distracted, like you are the one, you will be losing that mindset. So what I recommend you is, you should be something like ideal current source or ideal voltage source. Whatever may be your problem or your family problem, it should not affect your studies. It should not affect your studies. And say suppose if you are fully happy, say suppose assume that today is your birthday, you should not be over smart enough in order to celebrate that happy birthday. No, if you want to celebrate, okay, whoever is sending the wishes, you please respond, okay, thank you. Nothing but whenever you will be getting a notification in your mobile, if you are repeatedly responding to it, it is something like temporary enjoyment, not permanent enjoyment. So what we say is, if you are using mobile, use for some limited duration of time, but don't use for longer durations of time. So what is the current characteristics you got? It is something like a deteriorated one. It is something like a deteriorated one. Something like you think that your focus decreased. Your focus decreases. Your focus will get decreased, right? So this is under practical current source. This is under practical current source. Nothing but what is the thing that is going to happen means, when voltage increases, current try to decrease. When voltage increases, current try to decrease, right? Any doubts?
No, sir.
No.
Look at the things. We try to talk about what is the voltage, what do you mean by voltage source, and what do you mean by current source. And also I try to emphasize with respect to resistor. Now let us talk about inductors and capacitors. But before to that, see, for a resistor, I have written all the story. It is a linear element, it is a bilateral element, it is a passive element, it is power dissipating element, not a storage element. I assume that you have written all the things. Now, in a similar manner, let us try to write for voltage source and current source. In a similar manner, let us try to write for voltage source and current source. What is the first thing I wrote for resistor? What is the first thing I wrote for a resistor?
Linear.
Resistor is a linear element. See, linearity in a network, what it say is, if it is passing through origin, for every incremental values in voltage change, if you are getting incremental change in current, then that element is called as a linear element. This is one way of explanation with respect to network subject. With respect to signals point of view, what we will be taking is, there two properties should get satisfied, right? One is additivity and the second one is scaling. Both are getting satisfied means, then we are going to consider that one to be a linear one, right? Now you talk about the voltage source and current source. Is it a linear element? Its behavior is passing through origin. No. See, in the case of voltage source, we will be dealing only with respect to the voltage. With respect to the current source, we are talking with respect to only current. In the voltage source, what is the current that is being flowed? In the current source, what is the voltage across it? Now consider the scenario. For every change in the current value, voltage is a fixed quantity. For every change in the current value, voltage keeps on deteriorating. Right? This is one thing. Say suppose if the current is flowing in the negative direction, at that time what is the voltage? Curve? Right? Will the curve will be something like this? or will the curve will be constant, or will the voltage will be 0, is the question. So we have to tell whether it is a passive element or an first one linearity. We have to tell whether it is a linear element or a non-linear element. Whether it is a linear element or non-linear element. Linear element or non-linear element. Next classification you tell. Next thing what we have written with respect to resistor. Come on, hurry up.
Bilateral.
Pardon? Bilateral.
Bilateral.
Now you tell me with respect to voltage source and current source, is it a unilateral or is it a bilateral? Nothing but how we are going to connect, you are going to bother, or you are just connecting like that only. What is the third classification we made with respect to resistor?
Passive element.
Now you have to discuss, or you have to tell, is it a passive element or is it an active element? Is it a passive element or an active element? Next one. Is it a power dissipating or is it a power absorbing material? Power absorbing. Next one.
Not a storage element, sir. I mean
Not a
storing element.
storage.
Not a storage.
Energy element also, sir.
And storage element. This storage element you can tell it is an energy one.
Okay, sir.
Okay. Now you tell me, you please talk about voltage source and current source. Is it a storage element or it is not a storage element? You tell me.
Not a storage, sir.
It is not storing any charge carriers, you are telling.
Yes, sir.
Voltage source and current source, for your kind information, it is a storage element. In the sense what? It is storing some energy. If it is storing some energy, then only it can able to give it. One example I will give, see. For this explanation, you consider your family only. See, we are children and our parents, they are earning. You consider myself, when my parents are earning, amount is with them. Nothing but what? They are the storage element. They are having some amount. So what I am asking is, okay, I will be asking them to lend some amount of money. Then they will be giving. That not a storage element is what? A resistor. You consider myself. Now, voltage source and current source, it is a storage element or an energy element. So not a storage element, I have to cancel it. Next thing is it giving the power or it is taking the power? Nothing but it is a power dissipating element or power absorbing element.
Power.
Okay, now one thing. If you are getting very much confused with respect to power dissipation and power absorbing, now you.
Sir, it is both, sir.
Okay. Let us talk about that one later. Now you tell me, is it a passive element or an active element? Is it a passive element or an active element?
Sir, active element.
Active element.
Active element.
Now, what do you mean by passive element? Means, see, look at the thing. What do you mean by the passive element? Can anyone define what do you mean by passive element?
The devices which do not have their own energy.
Which do not have their own energy sources. Correct, no? So example for passive element is what? Resistor, inductors, and capacitors. So resistor, inductors, and capacitors will fall under passive element. Your voltage source and current source is nothing but energy elements. It is an active element. Now, I am giving an voltage source. You are having the positive side and you are having the negative side of the battery. Can you connect however you want? Hello?
No, sir.
Can you connect however you want? You can't connect however you want. You can't connect however you want. Nothing but what? how we are going to connect that restriction, it is there. That restriction, it is there. So I will be classifying it under an unilateral element. See, refer to any textbook of your choice. They will be speaking only with respect to resistor, inductors and capacitors and diode. Transistors they will be taking, and then they will be making a classification whether it is a linear, non-linear, unilateral, bilateral, passive, active, not a storage element and storage element. But here let us try to derive the same thing for voltage source and current source also. Let us try to derive even for voltage source and current source also. Now it is also a linear element, but a restriction is there. Rather than classifying linear or non-linear, we should tell that it is a constant element. Right? So based on this, I have put an asterisk. Nothing but terms and conditions do apply. Now we are familiar with respect to resistor. Let us talk about inductors and capacitors. Now inductors and capacitor, you try to draw or you try to relate with respect to, say suppose on the left side, if you are trying to draw the characteristics of an inductor, on the right side you try to speak with respect to a capacitor. Next, we are going to deal only with respect to DC. We are not at all interested with AC. Remember these things in your mind. In AC its behavior is going to change, in DC its behavior is going to change. Now if I am talking with respect to only the DC supply, voltage across the inductor, I will be taking it as V. The symbol is, I am going to take it as L. The current that is getting into, I am going to take it as I. The resistance that is being offered across the resistor, I am going to represent it as, the unit is ohms. Symbol is something like this. Similarly, what is the unit here? It is, can anyone tell me? The unit for inductor?
Henry, sir. Henry.
Or represent by capital H. How you can represent means, say suppose force Newton, NEWTON, all small case or capital NU, right? That is enough. Similarly 750 volts, VOLTS, all small letters you are going to write, capital or capital V you can write. However you want you can write, but don't club both the things. Capital HENRY I have not written. This like this only the standard authors do define. They will not be making this kind of silly mistakes. Okay. Now what is the voltage drop across? The inductor. Now you see, what is the voltage drop means, we will be taking it as V equals to I times of. Here you will be having one parameter J times omega L, or let us not talk about J over here, let us talk about I times of XL, where XL is something like omega L. Omega is nothing but 2 pi f. What is the frequency in a DC element? 0. So you are going to get voltage drop across the inductor as 0. Now you please think over, if voltage is 0, that doesn't mean that the current should be 0. No, the current may be 0 or may not be 0. So current is greater than or equal to 0. Or the best way I can write is, current can be any value. I can take any value. It depends on the next circuit. It depends on what is connected, like left or right to it. Now with respect to the inductor, what I told, voltage drop across the inductor is 0. Current can take any value. Right? This is how I explained with respect to an inductor. But when I talk about AC, what and all the things I told, it will be wrong. It will be wrong. So there, another way of explanation I will be giving you. Right? This is one thing. Next, under initial and final conditions, there again we will be talking with respect to inductors and capacitor. There again one more story I will write, or one more explanation I do. Nothing but, you see, understanding the resistor is very much easy. Understanding the resistor behavior is dead easy when compared to inductors and capacitors. Why and how? Let us get into series of explanation of with respect to network analysis. After 9 hours of lecture, when I will be asking you will be telling the understanding the resistor is easy when compared to inductors and capacitors. At last, I will relate these three elements with respect to your family only, and you yourself will tell that resistor is the best. Right? Now, with respect to the capacitor, if we are dealing, this voltage drop across the capacitor, I am going to take it as V. The current that is getting into, I am going to take it as I. And capacitance is C. What is the unit of capacitance? Can anyone tell me?
Farad.
Farad. Okay. The unit is farad, or try to represent by capital F. On the left side, you see, if my font size is less, you can zoom it. You can zoom it manually. Voltage equals to 0. Can I tell it is behaving like a short circuit? So the equivalent thing, how you are going to represent means, you try to represent like this. In the L we have to represent, but current do exist. What is the voltage drop? Voltage drop is 0. Now look at the things. V equals to I times of minus J times of XC, or I times of minus J times of XC is what? 1 divided by omega C. Let us talk about the magnitude part. Let us not talk about the minus J element. So omega equals to 0, you will be getting for DC. Omega equals to 0 will be getting. So voltage do exist. Right? But it is taking what? Open circuit. When we are not having any closed path, charge carriers will not be flowing, current will not be there. So current, what is the value? 0. Current, what is the value? 0. Now you see, with respect to the inductor, what I made an explanation. Voltage is 0, current can take any value. In the case of capacitor, across an open circuit, voltage do exist, but current is 0. Try to write all these things in a short notes, right? And underline. Whatever I just made an explanation, those things should be there in that notes. Across the inductor, voltage drop is 0. Current can take any value. Current will be there. But across the capacitor, voltage is open circuit voltage will be having, but current is 0. In other way, what you can tell is, in a short circuit voltage is 0. In an open circuit current is 0. In a short circuit voltage is 0. In an open circuit current is 0. This one line of explanation, if you can able to understand, that is more than enough. Able to follow? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Now let me try to introduce the AC quantities also. But right now I'll be telling only one line of explanation. But once we are getting into the resonance part, you will come to know the real scenario of inductors and capacitor. There we try to praise only the resistor. There we try to praise only the resistor. See, I will include all the family members into the explanation. When I start with resonance topic, I will include all the family members into that resonance. Now look at the scenario. Understanding resistor, inductors and capacitor, if you think that it is easy only in a resistor, not in inductor and capacitor. Why? Let me explain. See, I have changed the notation also. If I want to represent the voltage, I should represent it as a small case, or I should represent in a small case only. Small v have written. Anyway, it is changing with respect to the time, so only I have taken it as v of t. If you want to take v of t, you take, or else you try to represent in small cases only as a small v, right? What is the current that is getting into the resistor? I will be taking it as a small I. What is the current that is getting into? I will be taking it as a small I. What is the resistance that is being offered? That is R. What is the resistance that is being offered? That is R. What is the voltage drop? Voltage drop is V equals to small I times of R. Now you see, with respect to resistor, V equals to IR. With respect to the DC supply, here also you got V equals to IR only. Is there any change with respect to resistor? Absolutely zero change. Absolutely zero change you got. Now, let us try to explain even for inductors and capacitor, then you will start praising inductors and capacitor. Let us talk about inductor now. See, if I am speaking with respect to inductor, like symbol capital L only I will be writing. Voltage drop across it, I will be taking it as V, and the current that is getting into, I will be taking it as I. Right? Now, what is the expression for voltage? V equals to L into di by dt. Now you see, you got to know that the expression is getting changed. We got to know that the expression is not is getting changed. There, what was the value of voltage? 0. Current can take any value. But here mathematically, how I am explaining the inductor means V equals to L into di by dt. L is the inductance that is being offered, and here the change in current it is bothering. So what I mean to say is, any change in current, inductor is not going to allow it. So it is acting like an current shock absorber. In your vehicles also you will be having the shock absorbers. Here also you will be having that current shock absorber. Any sudden change in the current, your inductor starts opposing. So it is referred as what? Current shock absorber. All these things try to write in a short notes kind of thing, or whatever the notes you are making right now, that one you try to underline or you try to highlight it. Now, with respect to voltage and current, we should plot ideal scenario and under practical scenario. See, if this is my reference current, what is the voltage? Voltage curve will be something like this. Under only inductor. Now look at the things. Voltage is going to lead current by 90 degree. Ideal scenario I can tell, or I can call it as under pure inductance. If I am talking about a pure inductor, you will be getting what? What is the line of statement I told? Voltage leads current by 90 degree. Voltage is going to lead, voltage leads current by 90 degree. 90 degree. But this inductor is something like spring kind of thing you would consider. It is made up of some resistivity material or some material which is going to definitely offer resistance. So that means what? There is some amount of resistor over there. There is some amount of resistance that is being offered. So if I try to plot the current versus voltage curve, then you will be getting something like this. You will be getting something like this. You are expecting the phase to be 90 degree. The phase to be 90 degree. Really the phase is 90 degree? No, the phase shift is not 90 degree. The phase shift is not 90 degree. So this is under practical scenario, right? Voltage is going to lead. Voltage leads current by theta degree, where theta lies between 0 to 90 degree. 0 to 90 degree. Very important. Very important. Right. Similarly, let us talk about a capacitor also. There, what is the explanation I made? What was the explanation I made? Voltage is it is acting like an open circuit. Open circuit means what? Voltage do exist, but current is not at all existing. But that explanation I can't write over here. Why? It is getting failed. See, V equals to L into di by dt I have written. In terms of current, if I want to write, how I can write? Apply integration on both sides, then I will be getting this expression. See, I am not at all mugging. What I did is apply integration on both sides. When I apply integration on both sides, I will be getting integral of V dt. I will be getting integral of V dt. L, if I am sending on the left side, it will be getting 1 by L. Integration of di by dt, that integration and differentiation is going to get cancelled out. So only I got I equals to 1 divided by L into integral of V dt. Similarly, here you will be having, in the case of inductor, you got V equals to L into di by dt. I will be getting the current that is getting flowed. It depends on the charge carriers. So I will be taking it as dq by dt. What is q? Q equals to C into V by dt. Differentiation of any constant, it will be 0. But with constant, one more element is there which will be changing with respect to time. So the constant I will be taking it outside. Why? Throughout my experiment, capacitance is constant. So C I have taken it as outside. C into dV by dt. So what we got is I equals to C into dV by dt. Unable to remember, I am having a simple trick. See, remember V equals to L into di by dt. Enough. Rest of the things is just copycat. Here V is there, try to represent by I. Here L is there, try to represent by C. Here I is there, try to represent by V. Nothing but you see this expression and you try to consider this expression. Wherever voltage is there, replace by current, and vice versa. Wherever inductor is there, try to represent by capacitor. Finished. You try to derive the current expression across the capacitor. Now the same thing, if I am asking you to derive what is the voltage expression, means simple. What you will be doing is nothing great. Apply integration on both sides. V equals to 1 divided by C into integral of I dt. If say suppose if you are too much lazy, try to copy this one also. This expression and this expression is similar. So what I recommend you is Anyway, we are master in differentiation and integration. V equals to L into dA by dt. Only this expression you remember. If you want the current expression, try to apply integration on both sides. If our memory is something like Gajni memory, we have to follow this method only. Capacitor, any changes in voltage, it is not going to allow. So it is referred as what? Voltage shock absorbers. It is referred as what? Voltage shock absorbers. Voltage shock absorbers. Now let us try to plot voltage versus current. Now here I will be taking the reference value as voltage. Here we will be taking the reference value as voltage. Reference value I will be taking it as voltage. Now current, what is the thing that is going to happen means current will be a lower value, but current is going to lag voltage by 90 degree. Current is going to lag voltage by 90 degree. One mistake we made. Here what, in the case of inductor, what I told, voltage is going to lead the current by 90 degree. Here differently we have to make. Sorry, here if say suppose if I am taking, if I am plotting for current over here and voltage over here, sorry, what we are going to get, current is going to lead voltage by 90 degree, or voltage lags current by 90 degree. However you want, you try to remember, not a problem. Current leads voltage by 90 degree. Voltage by 90 degree. Or you can tell voltage lags current by 90 degree. Voltage lags current by 90 degree. Current by 90 degree. See, as of now you try to remember both the statement, but as and on when you will be when your subject knowledge get increased, when I will be asking with respect to the capacitor, you should have a clear cut idea with respect to lead or lag. If one is leading means if I am reversing the statement, it will be lagging. Say suppose current leads voltage by 90 degree, or you can also redefine it as voltage is going to lag current by 90 degree. Right? This is under pure capacitance. If I am considering pure capacitor, this is the scenario. But really pure capacitor is possible? No. It will be having some resistance within it. Why? The material at the time of preparation of this capacitor is the big headache. We are not physically connect a resistor because of its material property. That resistance value we are going to take it over here. Now look at the scenario. Current, I am going to take it reference. If you want to try, if you are trying to take voltage also reference, no problem. Now current, now try to plot for the voltage also. Voltage will be something like this. What we expected, 90 degree curve. Are we getting? No. No. So here I can tell, here I can relate with respect to the theta. It is lying between minus 90 less than theta less than 0. If it is on exactly on 0 curve, if it is on exactly on 0 degree, if voltage and current, if both are at 0 degree, then it is a pure inductor, pure resistor. Then it is a pure resistor. See, for a resistor, you see, voltage is this much value, current is less. Why? Resistance being offered. Here, what is the phase shift? Phase shift is 0 degree. Phase shift is 0 degree. If you are very much comfortable with respect to phi, let us take phi, no problem. Instead of theta, you try to take it phi and you try to discuss with the things. Okay, no problem. You take phi or you take theta, both are same. But whenever we will be speaking with respect to the phase shift, most of the textbooks they will be speaking with in terms of phi only. Why? phase shift phi. So let us make use of the same convention. There is absolutely no problem. You can take alpha, beta, gamma, whatever the value of your choice you can take. Whatever the symbolic representation you want, you can make. Any doubts as of now? Hello?
No, sir, it's totally clear.
Now, my dear friends, you see, I've just made a two line of statements with respect to inductors and capacitor on one side and resistor on the other side. Now, if I'm asking you the question, understanding resistor is easy or understanding the inductors and capacitor is easy? Understanding resistor is easy. That's why we say in a family, understanding men is very much easy when compared to women. Jokes apart, like sometimes practically it is true also. So for the understanding purpose, let us relate the let us get the family members over here, right? For the explanation sake, it will be easy. I am not against women or I am not against Sasuma or Bahrani, but here what I try to emphasize is subject, like the effective communication should be there and effective subject knowledge should be there, right? Knowledge transfer should be there. Now let us do a quick revision. So we have talked about the behavior of a resistor, whether it is a linear element, bilateral element, passive element, power dissipating element or storage element, and we have talked about inductors and capacitor with respect to the DC excited. So the voltage drop across the inductor, I am going to take it as V, and the current that is getting into, I am going to take it as I. So what is the thing we will be deriving is voltage drop across the inductor is 0, nothing but it is behaving like a short. It is behaving like a short circuit for an DC excited one, but current can take any value. Similarly, if I am discussing with respect to the capacitor, in the case of capacitor, it is behaving like an open circuit for a DC excited one. So voltage do exist, but current is 0. Now for an AC excited one, its behavior is not at all changing. But in the case of inductor, V equals to L into di by dt we will be getting. If we want to derive for current, what we can do is apply integration on both sides. Then we have come up, we will be telling that inductor is referred as what? Current shock absorber, and capacitor you are going to refer it as voltage shock absorbers, right? Now in the case of inductor, voltage is going to lead current by 90 degree, but practically if you are considering, it is going to lead by 5 degree. That 5 is going to lie between 0 to 90. It can't be 90 degree. Why? It is not a pure one. It can't be 0. Why? It is not a resistive element. In the case of a capacitor, we got to know that the current equation is I equals to C into dV by dt, or if we want to express in terms of voltage, V will be equals to 1 divided by C into integral of IDT. So it is referred as voltage shock absorber. In the case of pure capacitor, the current is going to lead voltage by 90 degree, or we can tell voltage is going to lag current by 90 degree, right? So I made a graphical representation, but in the case of impure form of capacitor or a practical capacitor, if you are considering, here in that one also resistance do offer. So if I am taking that resistance into consideration, then the current is going to lead voltage by 5 degree. That 5 is going to lie between 0 to 90, right? Now if I am talking about the voltage source, we will be having the ideal voltage source and practical voltage source. In the case of ideal voltage source, whatever may be the current value, voltage should be a constant value. And in the case of practical things, as current increases, voltage deteriorates. Similarly, in the case of current source, you will be having two variants, ideal current source and practical current source. And in the case of ideal current source, as voltage increases, current is a constant value or a fixed quantity. In the case of practical scenario, as voltage increases, current too decreases. Already I have given you an explanation. See, in this what we are going to do is resistors are connected in a series, but in the case of current source, if you try to consider, there we try to talk about we will be discussing with respect to the elements that is being connected in parallel. Elements being connected in parallel. Now, with respect to the voltage source and current source, we have made a short summary kind of thing, that it is a linear element, unilateral element, active element, and a storage element. Strictly speaking, we should not talk about linearity or non-linearity, but if at all, if I want to compare it, I'll be classifying it under a linear one. I'll be classifying it under a linear one, right? So this was the explanation with respect to network analysis, that to the basics. So our target is in another 8 to 9 hours of lectures, we have to finish this network subject. Any doubts till now? What and all the things we have discussed?
No, sir.
Thank you for being on my channel. Please like the video, share this video with your friends, and subscribe to my channel Craving Gyan. All the best for your competitive exams. Thank you.